Got it. We have it geared towards folks who are already a little bit comfortable with Earth Engine, but if you're here and you're totally new, welcome. I think you'll still get a lot out of this just by following along and watching, so never fear. And you can feel free to get that worksheet open as we get started. There's a link in the chat, and there's also a bit link on your screen, but I'm about to get rid of that. So you can open up the worksheet. We'll be working off of that this whole time today. So if you're a visual learner, the worksheet's going to be for you. So a quick overview of today's workshop. We'll get started with some quick introductions, I promise, and then we'll discuss how we might link together all 50 years of Landsat imagery. And then we'll get going in the workshop. So like I mentioned this before, but if you're comfortable with Earth Engine, you can treat today like a workshop. You can try to follow along and be hands-on. If you're not as comfortable with Earth Engine, but you're just excited to see what's possible, you can follow along and treat today as more of a demo. So all of the instructions will always be there for you. You can come back to the worksheet at any time when you're feeling it. So don't feel pressure to go hands-on today if you'd rather just watch. So a big thank you again to introductions. A big thank you to Declan and Andy, who are both here today to provide support and help you all get through the workshop. Declan, I don't know if you want to say hello.
Hey everyone, happy to be here. Declan, geospatial analyst at Conservation Biology Institute.
Awesome. And then Andy, you already introduced yourself, but you can give a wave, say hello as well.
Hi everybody. Yeah, I'm Andy. I'm part of the SCGS conference committee. Great to have you here. I'm based in Berkeley and work for the University of California in geospatial.
Awesome. Thank you guys both for being here. They're volunteering their time. We're so grateful. And you can go ahead and use the Zoom chat to talk with them whenever you need help with either Zoom or Earth Engine issues. And I'll be monitoring the chat as well, so I can try to answer any big questions out loud. So a little bit about me. I'm a PhD candidate at UC Berkeley, and I use Earth Engine to study the ecological impacts of Indigenous stewardship. And I'm lucky to be partnering with the Amamutsan tribal band. And so today our workshop will focus on an area of Amamutsan homelands. So I'll provide some background about the tribe very briefly and where we'll be heading today. So the Amamutsan tribal band's homelands are in California, where many of you might be, just south of the San Francisco Bay and east of Monterey Bay. The tribe founded the Amamutsan Land Trust, which works to steward lands which are shown in this map on the right. So you might be familiar with some of these gorgeous areas. So the tribe and the Land Trust are doing incredible work to steward those ecosystems I just showed you, and they're protecting a lot of their sacred sites. So I really do encourage you to check out their work at these websites. Fire in particular has been a critical part of these ecosystems for millennia, and AMLT's cultural burning program is expanding this type of Indigenous stewardship, which you can see in the photo on the right. So it's really exciting work, and I hope you all can check them out and support them. And today we're going to be looking at some of those landscape changes that have happened along that coast. So now it's time to meet all of you. If you're comfortable, you can introduce yourself in the Zoom chat with your name and where you're joining from. And then optionally, you can include if you'll be treating this as a demo or a workshop. So I'll do a little example in the chat. So I'm Annie, coming from Berkeley, which are Chochenyo Ohlone lands. And I'm going to treat today as a workshop because that's what you all came for. So while people are starting to type in the chat, if you're comfortable, I'll just mention, and I say this at the beginning of all my workshops, that I am aiming to build an Earth Engine community that is respectful and mutually supportive, where we acknowledge that we're growing together. So this can mean a couple of different things. It could mean that we're sharing our methods, we're crediting others who helped us, and we're offering and asking for help without judgment. So if you have ideas about growing that community or what you thought of this workshop once you're done, please share them with us, and you can reach out directly to me, and I'll have a feedback form for you all at the very end of the workshop as well. Okay, we got some people coming in. Some people really excited about the workshop, some people doing a demo. Oh, thanks, Andy. Andy dropped the map where you can get a sense of some of the tribes in your area. That's totally optional, but yeah, something that I think is great to include. Okay, great. It's so good to meet all of you. Thank you for joining us. Thanks for being here. This is a really, this is a great group. I'm excited. Okay, now let's talk about LandSatLinkr. This is the tool that we'll be using today in Earth Engine. Super exciting. So as many of you already know, Landsat satellites have been imaging the Earth's surface for 50 years as of this year. So 1972 to the present, 50th anniversary, very exciting year. And it's the perfect year to talk about how to use all of that data at once. So while we do have 50 years of continuous Earth observation and there's great opportunity there, there's also some challenge. Technology has changed since 1972 when Landsat 1 was launched. And the Landsat satellites use 5 different sensors, and I'm sure many more in the decades to come. What I've done here, you can see the colored bars show each of the Landsat satellites over time. And then these boxes, colored boxes, are showing 2 of the main sensors we'll be talking about today. So that's the MSS, or multispectral scanner, and then the TM, or thematic mapper sensor. And then there's 3 others as well. There's a lot of work that has harmonized these final 4 sensors, TM with ETM, OLI. And so you see a lot of great time series analyses that go from 1984 to the present, or 1982 to the present. What you don't see a lot of is the full 50-year archive, and that's because it's challenging. MSS is a very different sensor. And so LandsatLinkr is this wonderful method of linking together MSS with these 4 more recent sensors. Okay. Are there any questions so far? Particularly if you don't yet work with Landsat data, totally understandable if that didn't make sense yet. So don't be shy. Okay, so how do we link these very different sensors together? You might imagine that it's very complicated. And here's sort of a workflow diagram of what the initial method of LandsatLinkr looked like. And you can see it's very challenging, tons of steps. Luckily, Justin Brayton on the Earth Engine team has written LandsatLinkr to work in Earth Engine, which we'll be walking through today. So this slide is really just to give you an appreciation for what all of his scripts are doing for us. So first, LandsatLinkr is assembling image collections across the 5 satellites that carried, or 5 satellites that carried the MSS sensor? Maybe. That sounds right. It's filtering those images for different quality markers. It's calculating top of atmosphere reflectance, and it's applying an MSS specific cloud mask. It's also going to allow the user to manually exclude MSS images that look terrible. So they might have scanline issues or other noise, sort of these artifacts of that older sensor and older satellite. These cleaned up MSS images are then converted to a pseudo TM image by building a relationship between all of the overlapping MSS and TM images for a given area. So you might remember from that last slide, Landsat 4 and 5 carry both sensors. So we do have this beautiful overlap period where we can compare and say, okay, here's what the MSS image looked like on this day. Here's what the TM image looked on this day. Can we create a relationship between all of those bands and then extend it back, sort of fix up the MSS archive based on this relationship of the overlapping images? So then MSS is converted to pseudo TM, and it's all grouped together, and you can track changes over 50 years. So that's very exciting. LandsatLinkr is important for a number of reasons. This is just my plug because it is a little bit complicated as a workflow to add those extra 12 years. Here's why it's critical. I don't have to tell you all that awesome stuff happened in the 70s. There's some really cool Earth changes that occurred from 72 to 84 that a lot of our time series aren't capturing. MSS imagery also reveals critical changes in certain important historical context for landscape conditions today. So there are some forest structure papers that I've actually cited in today's worksheet that you can check out that use LandSatLinkr to say, 72 to 84 helped us predict conditions in forest structure today. So that's really exciting stuff. It's worth taking extra time to check out if MSS imagery in your study area and for your study question can really add value, because I think they might. So last thing, I'm sure you can predict that there are a couple limitations here. It's not just magic, pseudo TM imagery. There are some important factors to consider before you're going to use MSS data in your work. So the first thing to consider is that relative to the TM imagery, MSS imagery has fewer bands, it has coarser spatial resolution, and it has more limited radiometric resolution. Essentially, fewer shades or colors are distinguished in a given image. So LandSatLinkr is synthesizing bands and resampling spatial resolution and stretching the MSS data to match the TM data. But this means you should really be cautious when interpreting changes in the time series. LandSatLinkr is really best for things like time series visualization and major disturbance detection. It's not as well suited for subtle changes, like how's maybe the quality of a certain habitat changed over time. Take the MSS data with a grain of salt for those more subtle ecological analyses. And then the last thing to mention, and this image is just showing you that, here's the MSS sensor in the bottom. It's just got those 4 little bands, so you can tell its spectral resolution is greatly reduced compared to the other sensors. There's also the issue of global coverage. So the global coverage of MSS is not great, and this is due to a number of issues with data storage and collection back in the 70s and 80s. And so if you're studying, for example, the Amazon, MSS data might be terrible for you and not add a lot of value. So just things to consider. And unfortunately, it might not help everybody, but we're going to give you the tools to check it out on your own and see if it will. Okay. Are there any questions on that sort of brief overview? I'll take it back to this slide, which I think is a really good visual. I'll just pause for a moment. Okay. So there's my email in case, and I'll drop a feedback form, like I said, at the end of the workshop. But if you have thoughts or you got excited about certain ideas during this workshop, please get in touch with me. I'd love to talk with you about it. And we're just about ready to jump into the workshop. So again, I'll be walking us through the workflow. You can treat this as a demo, getting to follow along with me, or you can be, hands-on, following along in your own Earth Engine window. Unfortunately, we don't have enough time to run every single step of LandSatLinkr from start to finish. We will be running the tricky ones that involve a little bit of user input. So we think you'll be very prepared, but it does mean that we'll be pulling some pre-baked cookies out of the oven in the final step. And this worksheet is really written so that you can self-pace through all of these steps at any time. So please don't stress if you start to get lost, just enjoy the show and know that you have all the tools to do this on your own at any time. And you can reach out to me at any time for help. Okay. You'll need 3 things to get started. The first is the worksheet, which I will drop in the chat again. The second is a browser window, maybe Chrome, where you can open up the Earth Engine interface, especially if you're treating this as a hands-on workshop. And then the third is my Zoom window, if you find it helpful to follow along with me. If not, you can just get rid of my window and just listen to my voice. But a lot of people say that juggling those 3 windows can be challenging. And so you can use the Command and Tab keys on Mac or Alt and Tab keys on Windows to rotate between those 3 application windows, if that's helpful. That's some feedback we've gotten in the past that folks love that little trick. Okay, I'm going to open up Earth Engine. Oh yeah, and I promised I would drop the link to the script in the worksheet. So there it is in the chat. I'm going to open up Earth Engine and then share that screen. Sorry, gotta juggle all the windows. Awesome, I'm seeing some folks are in the worksheet, so I'm gonna share my Earth Engine screen. If you're in the worksheet, and I just have that pulled up on the side, but I don't think it should be blocking your view. Andy or Declan, let me know if that's the case. If you're in the worksheet, you can scroll down to step 1, set up your script, which is on page 4, top of page 4 in the worksheet. Okay. Any questions as we dive in? Is anyone having trouble getting into the worksheet or Earth Engine? You guys seem like a really easy crowd here. Okay. So if you've opened up the workshop script, it's going to be called LLR LandsatLinkr workshop, and then today's date. Because I've given everybody read-only access to the script, you're going to need to save a copy to be able to edit it, which is what we recommend you do. So I can make some change, and you'll go up here to the center and click Save As. We do recommend, if you like using script folders, we recommend you make a script folder for all of your LandsatLinkr scripts, because you might find you use a different script for every study area that you analyze. That's been our experience. And by our, I'm talking about Justin Braden, who's the developer of this tool in Earth Engine. So if you want to make a folder to hold all your LandsatLinkr scripts, just going to go to New Folder, and oops, okay, yeah, and then I can decide what to name it. I already have a folder for today's workshop, so I'm all set. And then you can save the script as something helpful to you. So maybe save it as LLR workshop or something similar to help you remember. Let's talk through some parts of the script as we're getting that set up. Folks are saving their own copy. One thing you'll notice in this script is we're using what's called a switch statement in JavaScript. So you'll see that we use a very simple variable, LLR step, which right now is just set to 1, to go through each step of LandsatLinkr in line. So LandsatLinkr, each step depends on the previous step being completed, and that's why we've got to go through one by one. And that's all that the switch statement is doing. It's saying, okay, if it's step 1, just do this and then stop. If it's step 2, just do this and then stop. So that's sort of the workflow of the script, which might look intimidating at first, but really it's just a step-by-step system. And the second thing I wanted to point out about this script is that we are importing the LandsatLinkr package. This is very similar to importing a package in Python or some other programming language, if you're familiar with that. We're using the require function in Earth Engine to essentially import Justin Brayton's script called LandsatLinkr, which you can see down here, as a package. We're saying call all the exports from that script LLR, and then you can see, just like we would in Python, we're going to say LLR dot and then call the function from that script that we'd like to run. So that's why this extremely complicated, very intensive workflow is just 100 lines of code. It's because Justin's really cleaned it all up and put the functions away in a different script, and you can always check that out if you're curious about what does that script look like. I think I link it. Yes, okay. In the worksheet on step 1.3, you can see I've linked the LLR LandsatLinkr repository to your, so if you click that, it'll add it as a read-only folder in your scripts in Earth Engine. And that's if you want to go in and dive in and say, what are these functions actually doing? It's really cool to get to see Justin's work up close. Okay, so does everybody have their script saved? They're excited? Folks are in good shape, no questions yet. Awesome. Okay. So now we're going to hit step 2, which is, I was just explaining this to Andy and Declan. LandsatLinkr is so easy. It truly is. But there are a few sort of administrative steps to set up the workflow that are the only place really where you can mess it up. The first step is that we have to decide which tile ID or which footprint of the MSS sensor are we going to focus on. We can only focus on one at a time. And the ID of that tile really flows into every other step. And so kind of annoying, but nailing down the WRS1, which is just the name of the world system that that sensor used, nailing down the footprint we're working with. So to do that, you're going to make sure LLR step is set to 1, which it should be by default, but maybe you played with it. And we're just going to hit run. Right now, this is just going to run this one function, which is the WRS1 granule selector. Granule is kind of a fun word for footprint. This will take a minute, and I think, especially with all of us using it, it might get slowed down. But you can see importing LandsatLinkr gives me some default warnings in the console. No need to worry about those. But now we've got the entire world is covered with these footprints of the WRS1 system. So I'm going to zoom in. And if you're doing a workshop, just go ahead and do the same tile as I'm doing for now, so that at the end of the workshop, your pre-baked cookies out of the oven look exciting. I'm going to click on, this is the San Mateo coast here, just south of San Francisco. I'm going to click right there and then just wait a second. It does take a minute to think. And you can see this includes the area where STGIS is normally held, so it's very close to home. Great. So we saw 2 things pop up. 2 colored boxes on the map, and then 2 IDs in this little box to the left. And so these are color coded to tell me which tile ID corresponds to which footprint on the ground. In this case, my study area overlaps 2 different tile IDs. Like we mentioned before, you can only run one at a time. So we're going to choose this one, this top one in red, because it overlaps more land area. That's what we're excited to look at. In the future, you can run both tile IDs in your study area, or maybe you have a huge study area, you have to run 5, and then composite them later as you would mosaic together any images in Earth Engine. So I'm going to copy this granule ID or tile ID, those mean the same thing. And this is already done for you, but there are 2 places where this tile ID needs to live for your script to work. The first is right here under the variable WRS1 granule. So this is already here, but you're going to pretend we copied and pasted this whole new tile ID into that area just so you get into the habit. The second place where this is going to go is in your asset folder. So we're not there yet, but just keep it copied or nearby. Great. I'm going to check if I missed anything in this step. I don't think so. Okay, you can go ahead and hit save as if we changed something. And like I said, step 3 now in the worksheet, which is on page 5, we are going to set up your asset folders. So this is sort of administrative task number 2 that, again, once it's set up, everything will flow from here. It's just kind of a weird non-scripting step that matters a lot. So you'll see this very soon, but LandsatLinkr exports lots of assets. And we'll walk through that, but basically a lot of different folders are required for these exports to work and for then the next step to flow and be able to call immediately from one of those, automatically from one of those previous assets. So those words are probably not as helpful as just visualizing it. I'm going to head over to my assets tab and make that bigger for now. Unfortunately, Earth Engine now has 2 types of assets. So what was already kind of an annoying administrative step is now possibly confusing, but hopefully I can explain this well to you all. So the goal today is to create an asset folder called LandsatLinkr, and then creating a folder within that folder, which is titled exactly the tile ID that we just copied from the map. Unfortunately, Earth Engine now has two types of assets. We have cloud assets and legacy assets. And so Earth Engine overall, the team wants us to migrate to the cloud assets. This is if you've enabled, I'm just clicking on the upper right here. I have my cloud project linked to Earth Engine. I think this has to do with the pay-to-play model of Earth Engine now, that folks who are not going to get it for free have to use credits in a cloud project and pay for that use. It's still free for nonprofit and research folks, but if you have a cloud project and you've gone through that process for whatever reason, go ahead and use that. If you don't have a cloud asset, that's totally fine. You're going to use your legacy assets folder, and it shouldn't cause any issues at all. Okay, so that being said, let's create those two folders. Your first folder is going to be called LandsatLinkr, just like I've created here. And so I'm going to go to New under Assets, then scroll down to Folder. And you can see I'll have, because I have a cloud project, I have two options. If the word starts with projects, that's a cloud project. If it starts with users, that's a legacy asset. Again, preference for the cloud project if you have it. And then I would type in LandsatLinkr and press OK. But I already have that folder created, so I'm just mocking this up. To then create a folder within that with the name exactly the same as the tile ID, which is 047034. You can go ahead and copy that text from your script just to make sure you're getting it right. And then again, you're going to go to New Folder. You can just create the folder within your base assets and then move it within the LandsatLinkr folder, or you can type out LandsatLinkr and then the / and it will automatically create that folder within that other folder. Okay, so you've just created two folders, LandsatLinkr, and then within that, your tile ID folder exactly as it's written. Folks are doing okay with that? Okay, once you've done that, you're going to create two folders within that one. So again, I'm sorry, this is a weird step that takes a lot of time. One of the folders is going to be called WRS1 to TM with these underscores. You really have to get the text exactly right because we have some automatically generated exports that are depending on these folders being there. And then the second folder within that is going to be WRS1 to WRS2. So again, I'll show you how to do that. New folder. In this case, I could type out the whole tree, LandsatLinkr 047034, and then I can type in WRS1 to TM. So that's how I would make that one folder. And then I would do the same. I would go WRS1 to WRS2. Again, please try to get the text exactly the same so that all of your exports work. Justin also wrote a Colab notebook to create these two final folders. So if you love the Earth Engine Python API and you just can't wait to have an excuse to use it, you can also use the Colab notebook that I've linked to in the worksheet. I'll just highlight that in case anyone can see my highlights live in the doc. And that really just saves a little bit of time if you're very fluent in that, in Colab. Okay, and then check out that screenshot in the worksheet of my asset folder structure. This was before I ran any part of LandsatLinkr. I've got LandsatLinkr 04734, and then the two folders, these were empty when I started the workflow. These were not here. So it's okay if you don't have all this stuff. It's because I've already run it so that we have something to look at once we walk through the whole workflow. Okay. that's the end of step 3. We are ready to start step 4, which is on page 6. If folks are having no trouble at all, maybe give a thumbs up if we're good to go. I know most of you are following along as a workshop, so I want to make sure we're pacing correctly. Awesome. Seeing some thumbs up. Great. Okay. So let's get started in step 4, which is on page 6 of the worksheet. Here we're starting to do stuff. No more folders. We're getting into it. And in this step, we're going to be creating an MSS reference image. This reference image is used for spectral normalization, as some of the sensors are inconsistent across the MSS time period. So this step will create an image named ref in your project's asset folder. So you can see mine's already there. That's what it'll look like. But let's go ahead and run it and see what the step looks like in real time. To run this step, you're going to go up to, you have to change 2 variables. The first is LLR step. We're going to set that to 2. And we'll look at what that does in a moment. The second step is going to be changing project path, which is on line 33 of the script. We're going to change project path to your asset folder. So I recommend you copy my asset folder and paste, and then just comment out my project path, because actually we're going to come back to that at the end, like I said, to look at those cookies fresh out of the oven. We're going to need my assets that are already exported. But for now, we're going to try running, getting you through the steps of this workflow in your asset folder. So this will be, if you're using a cloud project, it'll say projects / and then the name of your cloud project. And then assets, LandsatLinkr. This is why, if you didn't name it LandsatLinkr, definitely include that name, whatever it was here. And then if you are using legacy assets, it'll look like users, and then your username would be here, and then LandsatLinkr. Okay. Don't include a / at the end of LandsatLinkr. There's some automatic things that would mess up. And don't include this folder, the 047034. Just end it with your LandsatLinkr base folder. Okay, so we've changed project path. We've changed LLR step to 2. Some other optional variables. This is the step where you would get to decide some things for filtering the MSS imagery. The first is CRS. This is the projection system. We're keeping it at Maps Mercator, which is the native projection system that Earth Engine uses. You can also change the day of year range. So this is going to flow into all 50 years of Landsat imagery. What part of the year do you want to look at? In this case, we're looking at roughly June to September, which is the summer growing season in this part of California, and reveals a lot of differences between different types of vegetation. But you can play with the day of year range. The next one is the maximum allowable cloudiness, percentage of cloudiness for each of the included images. So in this case, we're saying as long as an image is 50% or less cloud coverage, we're going to use that image. This is different from the pixel level cloud filtering. It's just an easy first pass to get rid of some pretty cloud covered images. This last one, we recommend you just keep this at the default. This is the maximum geometric root mean squared error, and it's in units of a pixel. So this is controlling the maximum allowable spatial offset in units of a pixel. So how sort of misregistered can an image be? You might say, I don't want it misregistered at all. Then MSS imagery might not be for you. It's definitely not perfect. So we're sort of allowing this spatial offset. And you can play with that if you're coming up with some funny errors. But these are all variables you'd set at this step. Finally, we'll scroll down just so I can show you what we're doing. Case number 2, or step 2, is going to run export MSS ref image using those parameters. So we can go ahead and hit save, hit run, and we'll walk through our first export. You guys will be pros at the end of this. You'll be tired of exporting stuff. You'll see that the console is always going to print some type of please wait warning. A lot of these steps do take some time. So I'm going to head over to my tasks tab, and you can see I've got ran some other stuff recently. Eventually I'll see MSS reference image pop up as a task. You're going to hit run, and we're going to keep all of the parameters as their default. So you can see this is when it's counting on some of those folders being there without, that's why all those administrative steps are important. Okay, so you are going to hit run. I'm going to hit cancel because I've already run that and it will give me an error. Actually, I can show you what the error looks like if you already have it. An asset with that ID already exists. Okay, so you all are running step 2 of LandsatLinkr. That's fabulous. This step, I think will take between 5 and 15 minutes to export. I think that they compete with each other though for Google servers. And so if we're all running these really heavy tasks, it might go slower because we're doing it at the same time. Okay. Once that's done, you will get this ref image here. And unfortunately, LandsatLinkr does depend on the previous step being completed. So we'll start walking through the next step on my computer as each of yours sort of start to catch up. And we will also be taking a bathroom break just before 11 Pacific time. And so that'll also be a time for your task to sort of catch up. But you can feel free to drop in the chat, like my reference image exported, I'm good to go. Just to give everyone else a sense of, it would help me get a sense of where everyone's at. So we're going to cruise on to the next step. This is another thing that's great about Earth Engine in general, but also the way that LandsatLinkr works within it. Because these tasks can run in the background, you can keep using Earth Engine and not waiting for something to load in the map or something like that. So it's really set up to be user-friendly, even though some of these steps are kind of annoying. Okay. The next step, step 5 on page 6 of the worksheet, we are going to preview and filter out some of those really bad MSS images. So this is the critical step. Also a fun one, you'll get a sense of what do these images look like? What are we working with? So this step is going to print out little thumbnails of all of the available images that match your parameters that we just set in the previous step. We are going to try to remove images that have lots of discolored lines, lines that seem shifted, thin clouds and haze, which our cloud filter can't pick up as well, and then very bright or really dark colorization compared to others. LandsatLinkr will be able to minimize a few discolored lines and super thick, fluffy clouds. So in general, it's a balance between including more imagery, but then also wanting to make sure your imagery is really high quality. There won't always be a ton of MSS images, so you'll have to figure out where that balance is for you. So to do the next step, very straightforward. To run it, we're going to change LLR step to 3. I'm going to scroll down and just show you what that looks like. This is view WRS1 call or collection. So I'm going to hit save and run. You might not need to have the export done to run this. So despite everything I just told you, give it a shot and see if it runs. Okay, awesome. The mechanism by which we're going to exclude images is using this parameter called exclude IDs, which is on line 48 of the script. So it's essentially just a list of all the image IDs that you don't want to include. And you can see that in the console, we're getting the ID is printed right above the image in every case. And so you'll be able to say like, okay, I don't like how this image looks. What's the ID? Copy it over into your list of excluding images. So I've got some IDs here pre-populated, but let's walk through what this step looks like. So I'm going to go to var exclude IDs. I'm going to open up the list. And you can see it's a list of strings. So we are going to need to use quotes and separate each ID using a comma. So let's walk through which of these images we don't like. Which ones do we kind of want to exclude because they look too discolored or thin, hazy clouds, that kind of thing. So I'm like, which ones did I already exclude? Which ones did I decide to exclude? It looks like I did exclude this one. It looks a little overexposed and there's this big line. One line isn't a huge problem, so we might decide to include that one. Here's one that looks good. We got some clouds over here, but they only really get hazy over the ocean. They seem pretty thick on land and will probably get filtered out. Here's one that looks terrible. So this is what we mean by many discolored lines. The whole colorization is off. This is an image ID that I would definitely want to exclude. So I'm going to copy it and paste it into my list. And I'll just keep building my list that way. Here's another one I don't like. Copy that over. And you can see in some cases, here's one we do like. In some cases, you might say, you know, I didn't like any of the images that were in 1974. And then I'll show you really quickly how to tell the year. You've got Landsat MSS, this is LM. I'm not sure what all these numbers are, but then you'll eventually get to a 19. And that's generally going to be the year that that image was captured. 197 is generally going to be referring to the day of year that it was captured. So all of the MSS imagery are from the 1900s, so you can use that 19 to find the year in the middle. I think Justin and I both want to make it really obvious somehow in a future iteration of LandsatLinkr. But so you might say like, oh no, 1975 has no imagery. LandsatLinkr will use a dummy image to keep your time series intact. It will show a gap that year, but if it's really important for you to capture every year, then maybe consider rearranging some of these variables. So maybe your day of year range is going to be broader. You might have to do more filtering in this step though. So there's sort of this give and take. Another thing to note is that if you redo these filtration parameters here, you should redo step 2 where you exported your MSS image, reference image. So if you do decide to change those parameters, you got to go back to that step. Okay, so you're going to go through, you're excluding images, you might be paying attention to the year so that your image collection makes sense. Here's some hazy clouds that really don't look easy to filter out here. So I might exclude this one. Something else you can consider is that if this is your study area down here and it's not covered in clouds, then use that image. That's why the thumbnails are so helpful. Yeah, like this looks very green. Not sure why that image is so green. So that's another reason you might exclude one. It's just, in general, the coloring looks off. Okay, so you spend maybe 10, 20 minutes filtering out all of the IDs to exclude. You can either use your list that you've been populating, or you can uncomment my very complete list here. So to do that, you're going to highlight all that text, and then on a Mac, you're going to hit Command/. I think on a PC, it's just Control/, but maybe if there's a Windows user in the crowd, you can confirm or deny that. So now I've got my exclude IDs list ready to go. Okay, so that's step 5, which is filtering out those really noisy or clearly off MSS images. And this is when you as the user are super important. What days of year are you really looking at? What parts of the image are you really looking at? This is when a lot of your work comes into play. So it's not a plug and play kind of step. You got to use your own judgment for what you're looking for to filter it out. Okay. We are going to run one more step before a bathroom break, just in hopes of the export getting done in time. Okay, great. Control / on Windows is that comment uncomment shortcut. Okay, so we're going to try one more step, which is to prepare the MSS images. So this is step 6 in the worksheet on page 7. We're flying through the steps. This is correcting the MSS imagery within itself. So this is not yet creating the pseudo TM image. This is using that reference MSS image that hopefully is still exporting or has completed. This is going to say, okay, correct all of our images to that reference image so that our whole collection is spectrally normalized. Sort of like harmonizing within the MSS time series. And this is going to export an annual composite image based on the meteoid for each year in the MSS time series. So from 1972 to 1982. And then we will use that later to harmonize those to pseudo TM. So to do this step, this is when you're going to be like, this is a lot of exports. I'm going to change LLR step to 4. Then I'm going to come down here. This is running a function called process MSS WRS1 images using my parameters. So I'm going to hit save and run. And what this step is doing is creating 10 or 11 exports, 72 to 82 in your tasks tab. So when you can, you're going to cruise over to the task tab. Mine is timing out. This is kind of a heavy lift of a step. There we go. So you can see that all 11 tasks are populating and I have to run each one. Well, I already did this. You have to do this. You're going to hit run next to each task and then hit run again with the default parameters. You can see again, this is where the script is relying on those folders that you created being populated there. So you're going to hit run on all 11. This will only work if you have that reference image exported. Oh my gosh, someone just got the reference image. Okay, so if your reference image has exported, then I encourage you to run step 4 of LandsatLinkr and export as many of these as you can before you run for your water break or your bathroom break or coffee break. Just in case that, oh, someone else just finished. Oh my gosh, yay. Great timing. Okay, so if you can, run these next tasks. Okay, and then I'll show you quickly what that'll look like. So in WRS1 to WRS2 folder, you see I've got my 11 images, 72 to 82. I had to ask Justin what a meteoid is. A lot of us in the Earth Engine community might have used the annual median composite, where say we have a collection of NDVI images over a year, and we take the median at each pixel for that band. If you had a 3-band image, red, green, and blue, it would take the median red for that pixel, the median green, and the median blue separately. So not trying to find one date that was sort of like a median cluster across all bands. It would just be treating each band independent of the others. The meteoid is using sort of a clustering algorithm to find the median value across all bands that's an actual observation rather than independent band by band, strictly the median. So this is just another way of taking an annual composite that is trying to get at this like center metric. Awesome, Joel's got his reference image, that's great. Okay, so that's just a fun fact. Justin likes the meteoid. You can always check out his LandsatLinkr script in more depth if you are curious and want to calculate your own meteoid for your own work. Okay, so run step 4, start exporting or start running these tasks to export those images. But again, no pressure, because you can see mine are here for us to use I think we will need that time-wise, because each of these images might take, again, 5 to 15 minutes. Okay. Are there questions before we break? Pull up the chat. You can also feel free to unmute. This is a really small, chill group. So if you just want to ask your question out loud, I'd love that too.
Hey, Annie, Joel here. I was wondering if you can refresh Earth Engine. Like I was having an issue uncommenting the block of excluded IDs. Like for whatever, I think I need to restart my computer or something. Does that does it kind of pick up from the last process you ran, or does like a process that's underway, does it continue to run if you refresh?
Yeah, that's another great, this is such a good question. The tasks will continue running in the background, which is great. We don't mess anything up. If our computer fully crashes, Earth Engine has already received instructions, and it's sort of doing it in the background, exporting them to your online account. So you don't even need to be there, which is a great function of the task tool. So whenever you can, use tasks. It's fabulous, it's foolproof. In terms of what you've written in the script, it will, if you refresh Earth Engine, you might have to then go find your script and click on it, but it will go back to whatever was most recently saved. So that's why I'm always trying to save and then run, because I've lost work that way before. If I do too much on Earth Engine and it crashes, I lose what I wrote. So unfortunately, it's not like Google Docs. You have to save it all the time. It's a bummer. Got to get Google on that. But that's the only thing you would lose. I think that's okay. In this case, you could always click again on, if you go down to your reader script folder, you should be able to see my my folder, the SCGIS folder with this workshop script. And so you could always open it up, change the project path to your project, and then keep going, hopefully without too much trouble. So that's sort of a long answer. I'm just rambling about Earth Engine, but did that give you the information you need?
Yeah, thank you.
Awesome. Anybody else have questions before we take a quick water break?
Any other question, not related to this script, but about the cloud assets, because I noticed that that's a new thing, and I'm so grateful that you explained it, because I just kind of ignored it for a long time. Do you think that's something that we're all going to have to do, is sign up for a cloud asset, and then how do we do that for free? I mean, my account is my personal account, not linked to school or work. Do you have to do that through a professional account to make sure that it's nonprofit or academic?
Great question also, and I will try to answer it, although someone
I know you're not a Google Earth Engine representative, but yeah, any hints would be great. If you know, any advice you can give would be great.
Yeah, definitely. So full disclosure, this is my understanding. We'll see if it's correct. I'm on my personal Google account for my Earth Engine stuff, and I created a Google Cloud project to link with Earth Engine with no problem. I think you do have to provide payment details to create the cloud project and have it run. But my understanding is that it's either one of two things. It's either that because my account is registered as a free account on Earth Engine, I will never be charged, or it's like I'm below certain quotas that are allowed to the free accounts. And so that's why I'm not charged. I think it's the first one. I don't think.
Yeah, I think you're right. There is a Google Cloud that, as long as you don't exceed, like, well, I thought it was related to storage, but I was wondering if they also would charge for processing, because I used to be able to do a lot more, and they've kind of reined in the amount of processing power you're allowed to have. So a lot of the scripts that I used to run won't work anymore, because it says, oh, you've allocated your maximum memory. So I'm wondering if it might be tied to memory as well.
Yeah, they did. Earth Engine got more popular, even just when it was still free for just nonprofit folks and researchers. And so they did have to sort of like limit the amount that every user could ask for in terms of memory or processing power. And they are really helpful if you're like, hey, I have this such a cool project. Can you give me permission to use more memory or processing power temporarily or on this script? And they are so excited to support your work. And so my experience has been you can always ask and receive that a special treatment. And then I don't think they're going to charge. It might be storage. Yeah, I think it might be storage limits, because I'm trying to think if I go to my Google, my cloud project, and I think you should just be able to click on your account in the upper right and it'll say like make a cloud project, that kind of thing. Create a new cloud project. It's going to give you these options. So yeah, I think I can provide, after the workshop, I can send out like how to create a Google Cloud project to link with Earth Engine, but I think they try to make it pretty straightforward. And so far, I think it's still very totally free. So encouraged to migrate, still not required. Just do it when it feels right. You could do it after this upcoming Geo for Good Summit, maybe once they've provided more information and you're more comfortable, that could be a good time.
Yeah, thank you.
Awesome. Okay, so let's take a bathroom break. I'll be back here at 11:10 or 10 after the hour if you're in a different time zone. So 11:10, 10 after Pacific. Great. So take a break, get some water, get those tasks exporting the background, and I'll see you back in 7 or 8 minutes. So we're going to keep going with, like I just mentioned, step 7 on page 7. So I'm hoping everybody's back. Great. Okay, this step is building the relationship. And so if you remember in the slides for the workshop, the overlapping images from Landsat 4 and 5 that captured both MSS and TM images, we're going to build a relationship between MSS and TM using that overlap specifically in your study area. And so this step has to be done just for each tile footprint individually with your filtering parameters. So this is the meat of LandsatLinkr. It's really exciting. So it's going to take all the overlapping images in your study area and build a robust linear regression to link the two sensors for every band, for each image pair and for each band. So this is this is like 100 linear regressions. And thankfully, Justin makes it really easy for us. So to run this step, oh, I should say, a lot of your tasks are still going to be exporting, and this step does depend on the previous step. And so this is sort of the part of the workshop when we transition towards pulling the cookies out of the oven in just a moment or two. And so I'm going to just walk through what this step looks like. But I think if you tried to run it, it would not work or it would create some issues. So I'll just walk through what this would look like once your exports are all done so that when you do it on your own, it's very clear you've already seen it. So I'm going to change LLR step to 5. I'll scroll down, show you what that looks like. This is export MSS to TM coefficient collection. So I'm going to hit save and run. And no surprise to this crowd, it is going to create some tasks. So in the console, it's just giving me the regular warnings. And then it's creating 2 tasks. One is the offset image to help harmonize MSS to TM, and the other is this big table of coefficients regressing MSS to TM. So you're going to run those both with the default parameters. And again, I don't think you'll be able to run this right now, and that's okay. I've already run it, so I can't run it again, as you can see. And so this is sort of just a walkthrough step to show you what it would look like. And then once that's done and those exports are done, and those do take some time, I think the coefficient table has taken up to 45 minutes for me to export. So it's a big step. Once those exports are done, you'll see MSS offset and then MSS to TM coefficient collection in your asset folder. Okay. So that is step 7. We're going to keep moving through the workflow. Even though I know you might not be on this step, that's okay. On step 8, which is just at the bottom of page 7 of the workshop, this is the big shebang. This is harmonizing your MSS images to the thematic mapper or TM time series using all the coefficients that were calculated in the previous step. And so just to note that we're not using the MSS images that Landsat 4 and 5 captured, because those also captured TM. So when we link together our 50 years, we're just using MSS for the years that we have to use it, which is 72 to 82. And no shade to MSS, it's just because it is that lower spatial, radiometric, and spectral resolution that we'd prefer to use TM whenever we have it. So to run this step, we are going to change LLR step to 6. And I'll show you what that's going to do. That is going to run the function export final corrected MSS collection. So this is very exciting. I'm going to hit save and run. And look at that, another 11 tasks for 72 to 82. These are the pseudo TM images. This is our final result, which is very exciting. And those are going to be exported into your WRS1 to TM folder. So if ever you want to check out one of these annual meteoids that's been pseudo TM'd, you can add each image to your map. You can really get granular and understand how LandsatLinkr, what the result looks like. So in these next steps, we're going to show you some really cool overview results, but you can really get into each year and try to understand. You might say, 74 looks really bad in my time series, and you can go ahead and investigate, what does 74 look like? You can also, oh man, the Zoom videos are blocking the close button. Something else you can do is, if you're curious about a given year giving you weird results, you can go back to step 3 at any time, run step 3, and check out the thumbnails. Step 3 will always exclude the IDs that you've written down. So you'll see here, we don't see some of the ones that we really hated. These are all images that are included. So you can always go back and say, I really don't like my results for 75. Let me go check out what images are being used in that year. Maybe it's only one, maybe you want to expand your filters and use more. So those are some options. But essentially, I'm getting ahead of myself. We have hypothetically just completed the pseudo TM harmonization of MSS to TM. Really exciting. Obviously, that's going to take forever and you might be a couple steps behind in your exports. Totally understandable. This is when you're going to switch your project path variable back to mine so that you can see what the results look like. So let's go ahead and do that. I'm getting ahead of myself though. We'll just make sure. So I'm on step 9 on page 8 of the worksheet. So this step is going to take all of the MSS imagery that we've just harmonized and link it with all of the Landsat imagery from later years. It's going to use those same filters. So my day of year parameter will be used to create those later years. So definitely make sure those filters make sense for your work when you run this on your own. And this is really the total of 50 years. We're about to check out that entire time series. So this is really exciting. So go ahead and change your project path variable back to mine, which should be projects/EE-analyse R Taylor /assets/LandsatLinkr. You can also, if at this point you've lost that text, I'll throw it in the chat. I don't know how helpful that'll be for folks. You can also just go to your reader folder in your scripts and click on the workshop worksheet or workshop script, and it'll be in there already. So either way, you're getting back to, you're going to be pulling from my assets. You can go ahead and comment out your project path for now, but keep it there because hopefully you'll continue the exports and the work as all those tasks complete. And we are going to change LLR step to 7. This is a really fun step. You can see we're running a function called get collection for LandTrendr from asset. So this is saying, this function is essentially going to look in your asset folder for the WRS1 2TM images, and then link those annual median composites with, it's going to create on the fly a collection from 83 to the present and link it with your existing assets. So again, you're going to need those assets to run this function. So you're going to be pulling from my assets. That's great. And then there's a function we've written that just displays it, adds it to the map. I'll show you what that looks like. I have animate collection commented out because it takes a really long time to run. And I added instead a thumbnail visualization. I love adding a thumbnail to a map. It's a really easy, quick way to visualize a time series. And so I encourage you to just check out or adapt this script to create your own thumbnail in the future. I'm really happy I found this script and get to use it. So plug for thumbnails. Oh, you know, I probably ran the wrong step. LLR step 7, and I'll hit run. I'll also just add on the thumbnail while everything's loading, you do have to create a region of interest, a rectangle. I couldn't get the thumbnail to work without it. It should just default to the extent of the imagery, but I think because there are some dummy images, because I didn't like the images for every year in this workflow, it won't work. So you got to get that AOI, which should already be in your script. Okay. So this step is a really critical step. We call this inspect the full time series because that's what we're hoping you'll do. MSS Imagery has all of those caveats, so it is important to check it out and say, does this look right to me? Does this match my expectations? It's okay if there are some surprises, like I didn't know there was a fire in 75, but being able to sort of gut check the imagery. So to do that, we're going to go to the inspector tab. And like I said, that function display collection is adding the full Landsat collection to the map so that when I hit, you can turn that layer on. It's just going to be a mosaic of recent imagery. To see the time series, you're going to click on a given point. So here, I know this is where the CZU fire burned in August of 2020. So I'm going to click on a pixel in that area. And then because I'm in the inspector tab, I'm going to be able to see that full time series. So if you go full Landsat collection and then expand the word series, you'll see that 50-year time series. I'm going to click this expand button. And you can use this time series, click in a bunch of different places in your study area to say, does this look right? Especially if you see a big jump. You can see, I didn't like the imagery we had for 82. 83 has very few TM images, so a lot of times that's blank. Unfortunately, there are ways around that we can talk about in a future advanced workshop. And then 84, I do have some, I'm back to TM imagery. So basically we're looking for, are there huge jumps in values? Ideally you'd have an 82 and an 83 to assess, like, is MSS linking with TM or does this look wrong? Are there huge breaks? It's hard to tell because of that 2-year gap. But I'll click on some other areas just to give you a sense of the process of checking. Okay, so this has got some cool changes occurring. NDVI staying really constant. I'm not seeing huge jumps that make me concerned. If I did, or, you know, for example, if there's a jump in a year that doesn't make sense, and I go back and I look at my asset, and when I look at that year, you know, 75, and I add it to my map, I'm like, this seems wrong. You can head back to that, oh man, I have to move my video again. You can head back to step 3 where you're filtering out bad images and say like, okay, I need to do a better job in 73 or 75. Things aren't looking very good for that year. You can also say I need different days of year because I didn't like any of the images. I'm not willing to add them, and I still want information from that year. And so I'll expand the seasonality of the images, that kind of thing. When you do decide to incorporate new images or exclude images newly, you are going to have to go back and run from step LLR step 4. So, you know, yeah, you could also go back to step 2 to recreate that reference image. If you have changed any of the day of year stuff, you should do that. If you just added new stuff, decided to exclude or add back any images, then you're going to want to head back to step 4 and make sure that those changes flow through all of your assets. Does that make sense to folks? Sort of this like iterative cleaning of your time series process. Awesome. Karen's giving a thumbs up. Amanda, great. Okay. So it's not perfect, but here's sort of the way to reference, go back to your time series and keep refining it. So this is a NDVI time series of the full 50 years. And you can see I'm getting, in the thumbnail, that's what I'm looking at. You can see I'm getting some black years. Those are years for which I excluded all imagery. So that would be, in my case, 82 and 83. Okay. Great. So that's sort of like a final exciting step, but we did add one more step. This is step 10 in the worksheet on page 8/9. And again, you're going to make sure your project path is set to mine so that it does something cool instead of throwing an error about not being able to find those assets. So I'm going to change LLR step to 8. I'll show you what it's doing. This is running LandTrendr on your entire 50-year time series. I'm going to hit run so it can kind of just get started thinking. LandTrendr is a temporal segmentation algorithm that is built for annual time series of Landsat images. I'm going to move it over here to the, this is Big Basin State Park, which burned in 2020. So I'm just checking it out. And I'm zoomed in because LandTrendr, the results take a long time to load. Okay, what is LandTrendr? It's basically creating a fitted collection. It's taking that squirrely time series that we just saw in the inspector tool in our previous step. And it's saying, okay, what is, using different parameters to say what's definitely a stable state, or where was a big disturbance? Where's a change between two states? And then how many years did that change last? So it's creating like a fitted linear model in segments that it is deciding, you know, this is a segment for 2 years, this is a 5-year segment. So it's temporally segmenting that time series to clean it up and create a fitted collection for each of the bands separately. So you can appreciate why this is taking a long time. LandTrendr is a really cool algorithm. You can check out in the docs tab. Earth Engine has added LandTrendr as an algorithm that you can run. It does take some cleanup to run it successfully. There's also some great scripts in the eMapper lab. I can't remember what that acronym stands for, but you can run, I've linked to the LandTrendr repository, I think, below in the learning resources, probably. Maybe not. I'll add that to the worksheet. so that you can try out some of their test scripts. Those are a really great way to get started using LandTrendr outputs because it produces so many different outputs. It can be really hard to understand how to work with the data format and then also how to use it because each pixel for each band has this incredible fitted time series. Justin does recommend when you're using LandsatLinkr to use LandTrendr to understand the final results. He really likes the fitted collection because it's sort of like another check against some of the MSS noise. So it's another filter for saying like, okay, what does my time series, what was it most likely, what's ecologically important in terms of changes in this area? It's another filter against some of that lower quality data that might have snuck into your time series. So like I said, lots of outputs from LandTrendr. We're showing you one of them, which is the magnitude and year of the greatest disturbance during that 50-year time series. So this is a super cool visual of across the 50 years, what's the biggest disturbance in my area? Was it that 2020 fire? Was it something else? And then I'll show you this is the magnitude of change that's currently populating the map here, and you can tell it is taking a long time. You can see sort of the fire, I'm guessing, is what's popping up. And that's why we're seeing this really nice gradient of disturbance in areas where the fire burned with different severity level. But if that's the case, then the year of detection should be pretty uniform if it's all from 2020. So that's a really cool way to look at LandsatLinkr results is to run LandTrendr, and he's created this really easy function to do that. So why not? But yeah, that's the workflow. So I would love to take questions, or if anyone's getting stuck on any of the export tasks or curious about the filtering of images, that kind of stuff, let's get into it. We got some time to chat. And again, you can unmute and ask a question. I've got the chat open, so I'm happy to answer questions either way. Yeah, Karen, go ahead.
Yeah, I was curious, going back many steps, when you actually run, I don't know which, I think it was a linear regression to kind of match the MSS and TM data. And I believe the output, there were some coefficients. Can you visualize that so you can check how well those are aligned?
Huh. That's a good question. I'll start by showing you what the table looks like. So this is the MSS to TM coefficients. So you've got the blue intercept, blue root mean squared error, and slope here, and it's doing that for each band, for each image. So this is sort of a visual of what it looks like. I'm not sure.
Yeah, it's curious if it shows some sort of like statistic on like goodness of fit, or I don't know, how well the regression explains the MSS and TM, or like at least that how they're matched.
Yeah, the best measure I can see in this table is the root mean squared error. That could be a metric of at least relative to other images. You could say like, okay, my like 1984 image, which I don't think these IDs are, yeah, it's 120. So it's not, there's clearly more than one row per image, but you could say like, okay, my root mean squared error is looking really high in this given year, maybe. There's something like that you could do. That's a good question though. I wonder about that. I think the biggest thing would be if your results look bad in your time series. Yeah. That's really helpful information. Yeah.
And then MS offset, is that just kind of whatever is added to the MS band to kind of make it match the TM?
Yeah, that's, let me see if I can easily share my slides again, because there's a good visual of that offset. I'm gonna share my slides. This is visualizing that offset. So in A, it's just showing the two time series next to each other, and then B is showing with the offset, sort of how it's trying to account for those fundamental differences between the sensors.
Okay,
So
yeah.
that's the best visual I have of what the offset is doing.
Yeah, that's great. Thank you.
Yeah. Justin is really the creator and the math whiz behind all this. So he'd have great answers for you, but he couldn't come today, unfortunately. But we can bother him at the Geo for Good Summit. I'm sure he'll be there.
Yeah.
Yeah, so you can see, I can use the inspector here, but this is the year of detection of that greatest disturbance. And I should say the greatest disturbance function as it's written right now is really trying to get at deforestation. It's tweaked to look for really big changes. So you can always go to the LandTrendr scripts and change those default parameters if you're looking for different types of disturbance. But yeah, you can see the year of detection is 2020. That's the fire, the CZU fire in 2020. And this is really cool. I love visualizing year of change. This is an agricultural area. And so you can get a sense of how land use change in agricultural areas is really exciting. Like, what year did this go foul, or was it harvested? Obviously, it requires some knowledge of the area because it's just too much information otherwise, but this is a really cool output. Any other questions, comments? What did you think of LandsatLinkr? I know Justin would love to hear your thoughts. Gonna zoom around. While we're here, what I might do, and I really do hope you butt in with questions because they're so valuable. I don't always know if I've explained something fully, so I love getting your questions. They're all great. While we're waiting for the next question to pop up, these learning resources here at the bottom could be really helpful to keep expanding on this project. The first is to add that LandsatLinkr repository or folder to your Earth Engine account. So that'll show up under your reader folder. And you can see under the hood what each of the LandsatLinkr functions is doing. And this is going to be particularly helpful if you're like, I love this idea, I want to build from it, but make it my own. You could customize functions that way. Obviously, you'd have to make your own copy. These are the two publications that get closest to describing what LandsatLinkr is doing. And so I would cite both of these if you use LandsatLinkr. And I think I'll ask Justin what the best citation is for the using his package, essentially. That's another thing to cite. We created this GitHub tutorial back in 2020 to walk folks through LandsatLinkr. And so you can, this is another way to see under the hood what the code looks like. And then also, it's sort of like a worse version of this worksheet from a while ago, walking through each of the steps. So that's there for you. And then these are some of the workshops that are available to keep expanding your skills in Earth Engine. I love the guides. These are the developer guides where you can read things like, how are people harmonizing Landsat sensors, ETM and OLI to each other? And that kind of stuff is all helpful in the guides. And then I use the developers group. This is the Google group where people bother each other with questions. A great resource. So I encourage you guys to join that one. Yeah, and then why don't I add the LandTrendr repository as well? So this is set so that anybody can read it. I'll just add it. I don't know if I spelled repository correctly there, but that's another way to play around with all the LandTrendr scripts without having to reinvent the wheel, because it is a little complicated, I found. Okay, no questions coming up. I think what I'll do then is just quickly. Oh yeah, Karen, go ahead.
Sorry, I'll ask another question. So I really think you did a great job when explaining how to inspect the analysis and each step, and then what you're looking for, and then going back to the previous step. And I think one thing I would recommend is creating a visual to kind of just show that, like, okay, so you made a change here, now you have to go back to the step and rerun it, and because it's so important that you are checking at each step and really capturing what to look for, and those sort of tips, I think would be great.
Okay, awesome. Great idea. Yeah, I'll add that to the worksheet. I'm just going to make a note of that. Awesome. Oh yeah, and I forgot, please fill out this feedback form. It's anonymous, so, you know, be honest, and hopefully that'll help us improve, and I can keep making better and better workshops for everybody. So really appreciate that. I wrote that it should take 2 minutes. So you could do it right now while you're still on the Zoom. That'd be great. Really appreciate it. And that's
Hi, Annie. I'll pipe in with a question that's maybe you covered and I just didn't quite catch it. But
awesome.
So we're looking at 50 years of imagery and 3 different sensors, right? So MSS, thematic mapper, and then OLI is the newest one. So that's kind of I guess I'm not a statistician, so correlating of the TM and OLI sensors, is that done in like completely in step, I think it's step 6 or 7, where it kind of does that whole thing as part of a like, do you have any, you kind of describe that at all? I think it's just kind of curious what it looks like. I think, are those sensors like they're more like spec'd to match each other, right?
Yes, yeah,
Okay.
that's exactly right. And I'm hopefully just sharing my PowerPoint view here. You can see we're focusing really hard on incorporating MSS today because it's so different. It's different spectrally, spatially, and radiometrically. But TM, ETM, OLI are all essentially capturing the same information at the same spatial resolution. Definitely the sensors have improved over time, and you're going to find issues with TM that you won't find in OLI, but they're way easier to harmonize to each other. So you can see here, I kind of want to zoom in a little bit. This is just showing spectrally how they're similar. This is OLI and OLI2, which is on the Landsat 9 satellite, which launched in the last year. So very exciting. You can see that there are some differences, annoyingly. Here's ETM and TM, which are the most similar. But there's still some work that goes into harmonizing ETM and TM to OLI. So, and you can see OLI2 is very similar and hopefully won't require that finagling. Let me see, there's a great Earth Engine harmonize TM and OLI. There's a great page on this. This is a tutorial. And essentially my answer to this is you can go in depth on this as you would like. There's some studies on why harmonization is important, and it's actually pretty straightforward. So it's using some coefficients that someone else has developed and applying them to each image. So here's a function someone's written, ETM to OLI. And they're also going to talk you through cloud masking. That's great. So it doesn't take too much time. I can show you also what's happening under the hood in the script that we just ran. So in get call for LandTrendr from asset, I'm going to go to LandsatLinkr and show you what that function's doing. So now I'm in Justin's script. This is showing us under the hood what's happening. Right, we had to use a dummy image for 1983 for this workshop because, and we'll change this back once we're done, but right now 1983 is sort of shorting out the algorithm. So apologies for that. You get to see some of that fun stuff happening. But you can see we're adding from asset all the MSS imagery. We're creating this fake 1983 image. It's just a blank, so it won't influence your analysis. And then you can see he's running, gathering all the TM data here, and then combining it, I think, gather TM call. I think some of these, this function in get meteoid might be running that harmonization in the background, but I know he does harmonize TM to OLI in LandsatLinkr. So when you're getting that combined call collection, it's already harmonized for you. There's also some good example scripts. Let me see, no matches in the examples. No matches. Oh man. Okay, well, there's that cool tutorial on Earth Engine to harmonize. So optional, but I think a lot of folks are doing that now, acknowledging some inherent differences between the sensors. But Earth Engine makes it really easy just to add them together. So either way.
Cool, thank you.
Yeah, no problem. Go back to our script. Any other questions from folks? I think I might let us go a little bit early to keep your Zoom stamina high for the coming week. I know folks are really excited for the rest of SCGIS, and I'm so thankful that you kicked it off with us today. I really love talking about Earth Engine, as you can tell. So go ahead and fill out that feedback form for me. I really appreciate it. And I'll make sure that I'll pass on all this excitement to Justin, because I know he's worked really hard to make this accessible to everybody. And I know he'll love that feedback as well. I guess one last thing I'll say before we sign off is that we are working really hard to get it going in the Python API, because there are some fun things that Python will do better, including that 1983 issue. So look for that. We'll try to find ways to publicize that once it's looking really good and we've got all these steps sort of built in the way we do here in Earth Engine. Okay, great. Well, thank you guys so much. I hope you have a great conference. I can't wait to see you all in other sessions. Good luck to those of you presenting. And hopefully I'll see you guys at Geo for Good or at a future conference. It's great to see everyone.